Alright, draft physics video. Yay. Anyway, so I've been watching this Susskind stuff with dinner and such, casually. And it does bring up a subject that I just thought I've talked about it before, but I'd like to talk about it some more because it seems another one of the parts that's very elemental to their understanding of reality. And the necessity to create this wave thing. How they've incorporated in a sense that they can't extract it now that they've put it in because of these contingencies they've placed on top of it. And it has to do with this idea of momentum and photons having momentum when all of their formulas are basically, mass is a constituent of momentum. And they're saying the photon doesn't have any mass. So they can't do the normal formula, so they do this abstraction of the formula, which is a lot like what they do to electrons, which is they give them an artificial frequency based on their velocity. They call their velocity a wavelength to make the math work. So anyway, it's this whole notion that photons and their frequency has something to do with their energy, that they're somehow more energetic as tons, as a photon. So again, this goes back to the whole, if they're wrong, and I think they are, about even how they define what a photon is. They're not recognizing that it requires 2 tons to make a photon, to make something that has a wavelength. It has to have a beginning and an end. And it can only have that if there's 2 of them. Cannonballs can't have a frequency if you only fire 1 cannonball. There has to be 2 of them, at least, as a minimum. So, I've made the argument that they've misunderstood this concept and that the photons themselves all have the same energy. And arranging them with a frequency that's short requires energy, because you have to create something that's very fast, that happens quicker than what would be the Planck field pressure. So it's kind of, if I made an analogy, spring's not a really good analogy because springs get tighter as you compress them, and it's more like it's the opposite effect. So there's probably something better to analogize it to. I don't know whether a spring getting pulled, that gets tighter as you pull it. But it's kind of like gravity. Pushing something off the surface of the Earth is a lot harder than pushing something once it's 1,000 miles up, let's say. It's a lot easier to push it once it starts to go. It gets easier and easier. And that's sort of the kind of spring. So it's like a reverse spring, if you can think of it that way. And that's what electrons are bound in all the time. So all of these charged particles are always going to go to the quietest spot. They're just going to be pushed, and they won't stop moving until they find a place where they can just jiggle. They can stay. And that's what they do constantly. They're constantly changing their position to find a quiet spot. They're not circling and doing all this other stuff. No, they're looking for a quiet place. And when a photon hits an electron, what it does is it gives it a jolt. So it's like me kicking the moon a little bit out of its orbit, pushing it out. Now if I push it a little bit, it'll come back. Okay? But if I push it a lot, it'll fly out of the Earth's orbit. So it just has to do with how much I push. And so you can sort of understand that if it gets easier the further out you go, that means if you hit it with two things, okay, very rapidly, then it doesn't spring back before the second thing hits it. So I've made this argument about the tipping point, but that's what it really takes place. So it's not about having more energy, it's about applying the energy, recognizing that Planck's constant is pushing things, is creating the reflex much quicker than even the frequency of light. I mean, Planck's constant would be, cosmic ray kind of, it would be very, very fast. So an electron that's getting pushed by a photon is, before the second ton hits, it's already moving back to its comfortable position. The effect of the acceleration is already worn off before the second ton shows up. And so that's why the electrons can't be kicked out of their position by low frequency light. Because no matter how much of it you throw at them, at an electron, you just keep hitting it and hitting it and hitting it. If you're giving it enough time to rebound, for the spring to coil back, then you'll never break the spring. You'll never break the hold it has. But if you hit it quick, in succession, before it rebounds, then you're still in that weak spring area, the weak gravity, and the second shot will knock it out of the orbit. And that's what's really happening in electrodynamics and what happens to electrons. So let's understand context. Their whole theory is in my opinion, this misplacement of function. They've taken the photon, called it electromagnetic, when it doesn't do any of that stuff. Electrons do all of that stuff. Photons have minor, almost no properties, okay, beyond this polarization thing. But other than that, they don't have anything. They can come at a frequency, but that's not even them. That's something imposed on them. But they don't have any electrical or magnetic character at all, beyond the fact that they affect electrons. And electrons have all the character in terms of magnetism and electricity. They're a filter for the magnetism, and clearly their movement is essential to the migration of electricity, the propagation, I guess would be a better way to say it. So all of the properties are properties held by electrons, and it's the photons that affect electrons that liberate the properties of the electron, reveal them. I'm trying to come up with a word for reveal them, make them happen. So this whole idea of photons having more energy because they're blue light instead of red light. So the idea that the actual tons have more energy is a very false notion. They're moving the same speed. If you have the same number of them, you have exactly the same energy, quote unquote, going in. And the only thing that's different is just a gimmick of the electron. It's a gimmick of the orbit. It's not, like I said, if you keep failing to push the moon out of orbit, it wasn't that you're expending a ton of energy. You could be expending an awful lot of energy just poking it too slowly. And all you needed to do was poke it a little faster, and then it goes. So it's just a circumstance. It has nothing to do with the actual energy, the number of tons you've used up. Yeah, it's just a circumstance of what the electron is sensitive to and exploiting that. So they sort of break the concept of the energy conservation rules, and just as a matter of perspective, because they're assuming this enhanced momentum. So he keeps using the word momentum, describing photons, and then he uses the word, so it's the same word that photographer guy uses, which is kind of funny, magnitude. Then he starts talking about the magnitude of the momentum. And you're saying, how can you do that? Momentum's already a magnitude word. Momentum already is it's created as a word, a value, that's saying this thing has this much energy. How can you say it has more magnitude, that you can give magnitude to momentum? It just doesn't make any sense. And then they're starting to get into a conversation about amplitude, but that one's obviously just a representation of numbers again, volume. But again, the volume doesn't have any meaning if you're not recognizing that certain things at volume will never cause it to tip over. So if I don't fire the bullets fast enough, the thing will not tip over. It'll just keep rebounding and rebounding. The rebound will be faster than your next push, and therefore you'll never get into the weak gravity that's necessary to make that final escape, that extra velocity at the right time. So anyway, I think this is just another one of these fundamental things, and I don't think their evidence for any of their conclusions is, really solid, black and white kind of stuff. I mean, I haven't researched all of the high energy physics kind of experiments, and everyone that's possible for which they might draw some of these conclusions, but I think these conclusions are just based on the fact that they're going based on what goes in and what comes out. The simple Einstein experiment where infrared radiation doesn't move electrons, ultraviolet radiation moves the electrons. So the assumption is the ultraviolet has more energy, when no, it's just that the electrons are more sensitive to the higher frequency. The higher frequency pushing doesn't have more energy going in, it just produces more effect going out, more effect that we notice. And again, that's another argument here, is we only notice this stuff based on how it affects something. We can't see a photon in any other way than how it affects an electron. And that's it. There's no other way to detect or in any way know anything about a photon, all radiation, until it hits an electron or a proton. I'm sure that can happen. But that's it. And so then they invented this, so we talked some about positrons. This is the electron antiparticle, the positron. So there's supposedly they've created this positive electron that somehow flies around in the universe somewhere. Where, I don't know. Where does it hide when it's not being, because obviously the strength of the interaction between electron and electron, the repulsion, is intensely strong. And likewise, the attraction, which is the field pressure, the absence of pressure between like an electron and a proton, is strong. And there'd be no way to, without some mitigating, something in between, like the neutron, there's not much to stop this positron from constantly affecting electrons. Now, I would say there's no evidence of electrons being deflected by positrons and being influenced by positrons, and this is just a symptom of high energy cyclotron type physics, that you're creating things that don't really exist. There might be a piece of a proton and you're calling it a positron. It's not really a thing that exists in nature. It only exists in crisis. It only exists when something unusual, not something usual, happens. Because I don't think there can be a rational theory that enables these positrons to be freely floating about with electrons without them constantly creating all kinds of distortions in the field dynamics that aren't represented in any facts I know of. So anyway, I was just thinking about this idea of what would annihilate an electron if, let's say, electrons can be annihilated or converted into photons. This would again be an acceleration argument. So you can't accelerate photons. They're already going the speed of light. So all radiation's already going the speed of, well, all radiation that's not made out of nuclear bits. Electrons are protons. Obviously they call some radiation pretty heavy nucleuses. It's not exactly radiation. Those are, I mean, it's not radiation in the sense of the common, what I would commonly think of when you hear radiation. You think of little bits. You don't think of big blobs of nucleuses. But anyway, I don't want to confuse the subject because basically I'm saying that the only thing that's truly radiation is the gamma radiation, and the alpha particles and the beta particles are something that should be called something else. They're moving, elemental particles. So if we can call them elemental, I guess we could call quanta or photons fundamental, and then call the matter bits, the things that make atoms, elemental. Maybe that'll work. That's what I mean by this language thing. To explain this, you have to have terminology that it's agreed upon, and that's where it gets a little tricky. So anyway, so I was thinking about this speed of an electron that, theoretically, this argument is if you push enough quanta behind it, you accelerate an electron sufficiently that you will degrade its material, its internal function will become just as you will break complex matter, in my opinion, with high acceleration. The same is true for the electron. It's not an indestructible element. If you accelerate it near the speed of light, it will break. And it'll break into its constituent parts, which are these little elemental bits. They're just in a different arrangement that makes them exchangeable. They're tied to each other. And you'll break those ties. You'll knock all the bits out of the solar system, so to speak. So I would argue that the matter bits, the electrons, are a combination of quanta in the 3 dimensions, and that if you accelerate them very fast, you'll destroy the other dimensions, and you only have quanta moving the speed of light in the 1 dimension, so you'll release the quanta in the perpendicular dimensions, and you will have remaining the quanta moving the speed of light in the direction the electron would be moving, which would be the annihilation of the electron, if it was possible. I'm not saying that's what happens, I'm just saying that's a possibility, that what they're calling a positron is really just the effect on an electron of being accelerated by very high energy, quote unquote, very high frequency radiation. So it's getting pushed very fast in one direction very fast. It's being accelerated very fast, and so there's no time for the structure to reform itself, and so it's broken. Yeah. Like I said, these are new revolutions in particle physics, basic concepts. So again, these are just the basic concepts, and I'm saying this is where I think physics, it's gotten all of them wrong. Bent space is wrong. Time dilation in the sense of time being a dimension that you can bend is wrong. It's an effect that happens to material bits. Their function changes as you accelerate them. And this idea of waves, yes, there are certainly waves of things, but the waves are made out of discrete particles in clumps, in groups, in bunches, in arrangement to each other at a frequency, put simply. And that's the character of those quanta, is their frequency, because they don't have any other property besides moving the speed of light and their orientation of polarization, whether they're going to reflect off of an electron or whether they're going to be passed through an electron and admitted as a perpendicular, exchange a perpendicular bit or accelerate the electron through the reflection. Alright, yeah, so I mean I've drawn up some of this stuff in terms of the movement of particles, and so I don't need, I think, to go over that in this video again. But I mean, it's a simple mechanism. You know, once you establish these polarization, and you just give the quanta two flavors, and then you create matter bits that filter for the two flavors, and that way you can create complete low pressure and complete high pressure in terms of the reflections between them. Maximize the reflections between them, you have two electrons repelling. Minimize the reflections between them of bits trapped between them, and then you have the relationship of the electron and the proton, where both allow the excited bits, the quanta, to escape through perpendicular EMF emissions, and create a low pressure, relatively speaking. So yeah, so it's just another part of this physics where I just think they have the wrong perception. They just made a wrong, they went with this wave thing, and then they compounded the problem of waves by thinking of light as having more or less energy based on a frequency, when the frequency isn't energy. It's just makes it appear like more energy to us because it affects electrons because of their particular properties and sensitivities. Alright, so that's probably, I probably shouldn't go wider, but you know, you could just bring up all the fact that they'll never unify with, you know, bent space, quantum mechanics, wave theory, you know, virtual photons. They've just broken something. So you know, they've created a whole bunch of evolution, and it just isn't the kind of thing that, it's not like that. There's not a whole, it doesn't get complicated, it gets simpler. And I guess that's part of the problem, is they kept creating fields to answer questions, and the fields, they could give extraordinary superpowers to them, and they didn't have to account for anything. And just a, you know, critical error. So anyway, I think that's enough of a video. So yeah, I just, this, you know, and you could just, like I said, you can just hear it when he's talking about momentum. You know, because they come up with all these different ways to interpret something. You know, if you want to do wavelength in radians, then okay, then you do 2 pi times the frequency. And I mean, it's all this convoluted bullshit. You know, and he keeps saying, well, you're never going to get rid of these 2 pi's, and you know, but yeah, you can if you quit making it complicated and recognize that frequency isn't momentum. frequency isn't energy. Just isn't. The number of quanta is the real energy. That's the ball you have to follow, not the showboat of how electrons are affected. They're only one part of the mechanics. And if you're going to, I guess the consequence of it is that the difference you create will have an impact in the environment, in the sense that let's say you do have a high enough frequency to release an electron. The fact is you've now degraded the matter because you've pulled one of its electrons out. So in a sense you've consumed an amount of its mass, and that's where the conservation is showing up. So the real energy came from the matter you're degrading, where in some other circumstance you can pump the energy in, the same energy comes out in a different form, and there is no degrade. So you can pump electricity through and just create photons for free, versus creating photons that are really consuming the matter that you're creating the photons out of as a consequence of. I don't know if I said that perfectly, but I said it well enough. Okay. Anyway, so till next time. And so, you know, I got to do the I got the double slit experiment on my porch, and I just, you know, just so many things to get to, and I got the laser beam stuff, and I'm just still fiddling with them. I mean, I'm been taking these lasers apart, and you know, they have these cheap, crappy little plastic lenses, and you know, I just don't think you can do an honest experiment with a gimmick. It just seems like it's kind of a gimmick, this laser, because it's not really creating culminated light. It's creating light that spreads, and then it's taking a little cheap plastic lens and, you know, creating an artificial consistency that again has to be doing some creating artifacts, Newton's rings and that such. So, but anyway, I got to do some more. Lenses get very complicated. Anyway, till the next time and such.